Hi ladies, I'm going to go through the solutions for the test that you did yesterday, even though I've got your tests and I can't give them to you, but it's because I'm at home. But you can still look through the questions, and I've given you a copy of this test. So I guess if there were any questions that you think you had trouble with, it might be a good idea to consider, well, how do I answer that? And email me if you need help with anything else. Okay, so just send me an email and I will do my best to help you. All right. So part A, we're just looking at, so no calculator, so it's purely skills based. And you should be able to do all these questions without a calculator, except for the last one. So it's an extended response question, which you can use your calculator for. Okay, so the equation of the axis of symmetry for the graph below is, so an axis of symmetry just means it cuts it down the middle, so it's symmetrical. So your axis of symmetry, and hopefully this pen's going to work, goes down like that. So that crosses at whatever the x coordinate of the turning point is. So that is at x equals -2, and it will always be x equals something. When you get into methods, though, you will be looking at different transformations. So the axis of symmetry won't always be x equals, but for the majority of the time, it will be. So x equals -2. So the correct answer for that one is C. Question 2, compared to the graph of y equals x squared, the graph of y equals -1/2 x squared is. So we've done turning point form, but you're probably thinking, oh, it's not in turning point form. Well, it actually is. It just doesn't have a value of h or k. So when you think about this graph, okay, so let's just do your normal x squared graph. Oh, look how perfect that is. So that's y equals x squared. Now, this graph hasn't moved up or down, it hasn't moved left or right, but it has been reflected, and I know that because of this negative sign, so it's gone upside down. And this half is your value of a when it's in turning point form. So it just means that it's become wider. So your graph, probably not that wide, but it does become wider. So I'm just going to say that's -1/2 x squared. Now, before I was saying it can be written in turning point form, so let me just show you how it's in turning point form. Whoops, can I just change? Doesn't matter that that's a plus, but I'm going to make it a minus. Because -0 and +0 is the same thing. And then +0. So it is in turning point form. It's just we don't use the 0 and the 0 there. And you can see it hasn't moved. Its turning point is the same. Okay, it's just been flipped. So kind of think if this parabola was looking at its reflection in a lovely lake, and there it is. So it's a reflection. It's been reflected along the x-axis. So it's become wider and reflected in the x-axis. So the answer for that one is E. All right, question 3. The rule for the parabola with a turning point 1, 2 and y-intercept of 0, 3 is, so it's also drawn it for us. So we can write the parabola in turning point form. Hold on, before we start, you could do a process of elimination. So I know my value of hk, the coordinates of the turning point, is 1, 2. So that means my equation in turning point form is going to be something like x -1 squared plus 2. So I'd look at all these and I say, well, it can't be d because that's x plus 1. This is -2 and this is +1. So now I've given myself a 50% chance of getting it right. Well, then I've only looked at h. Now I'm looking at k has to be 2, so it has to be a. The value of a here, sorry, different a to this. This is answer A, and this is looking at whether it's been made wider or narrower or reflected. You can see it doesn't really matter in this question, but if there was a value of a, to find it, you just substitute in another point. So we've already substituted in 1, 2 for h and k, and now we just substitute in 0, 3. So y being 3 and x being 0. So -1 squared is 1. So a times 1 is just a. All right, sorry, I just had to pause it because I was getting distracted. Okay, -2 from both sides to get a by itself. So a is equal to 3 minus 2, which is 1. So rewriting that equation, going back up here. So I know a is 1, so I'm just going to write x minus 1 squared plus 2, and there's your equation. So if you wanted to know how to do it, otherwise you could do a process of elimination like I did at the start. All right, question 4. The equation of this graph is, so I'm looking at the different equations. So it's sitting on this point here, x equals 2. So what we effectively have is an x-intercept at 2. So your equation in factorized form is going to be x minus 2, x minus 2. Okay, because when you solve that, you get x equals 2. So using the null factor law. Now that's the same as y equals x minus 2 squared. And when you think about that, that's the same as a graph shifted across 2. Okay, now it excuse me, looking at whether it's narrower or wider, I'm not doing for this one because I'm looking at all the options and there's no coefficient for x squared. So that means a must be equal to 1. But if not, I do the same as what I did in the previous question. I would put an a in and then substitute a point in. So I would substitute in this y-intercept, which is 0, 4. But I know a is 1, so I'm just going to leave it as x minus 2 squared. But let's have a look at our options. We don't have x minus 2 squared. I've got x plus 2 squared here, but that's just to trick us. X squared minus 2 is not the same thing. X squared plus 4, also not the same thing. So we're going to say, well, it's got to be one of these two. And they're both in expanded form. So why don't we just go ahead and expand this? So we're going to get y equals x squared minus 4x plus 4. So your answer is B. Okay, so just playing around with both factorized and expanded form. All right, the x-intercepts of the graph y equals 2 times x plus 1 squared minus 8 are at. Okay, so remember your x-intercepts are when y equals 0. So let's let y equal 0. I prefer to write the 0 on the right-hand side, so I'm going to go ahead and do that. So let's put the 8 over to the right-hand side. Let's divide both sides by 2 now. So we've got x plus 1 squared equals 4. And I'm running out of room on the page, but it's all good. So let's get rid of that square sign. So we take the square root of both sides. So I've got x plus 1. Now, when you take the square root, you get both a positive and a negative answer. So it's going to be positive 2 and negative 2. And I'm just going to write those two solutions over here. And then I'll just get x by itself. So for this one, taking away 1 from both sides, and this one also taking away 1. So I've got x equals 1, x equals negative 3. Now, writing them as coordinates, that's 1, 0, and negative 3, 0. So just looking for those two. Are they there? I can't see. There we go. Sorry, it's written in the reverse order, but it's all good. Okay, moving on. Question 6, the quadratic rule y equals x squared minus 16x plus 40 when written in turning point form is. So you do need to complete the square to put it into turning point form. You can easily do that. Hopefully you've done it so many times now you're sick of it. So we take the coefficient of x, so negative 16, divide it by 2, square it, then we take it away. And hopefully I'm giving myself enough room, plus 40. All right, so now you're factorizing the first 3 terms. So it's going to be x, whatever is inside this bracket. So negative 16 on 2 is negative 8. And then I've got negative 16 squared. So negative 16 on 2, negative 8. Negative 8 squared is 64. So I've got minus 64 plus 40. And you'd probably look straight at the answers now instead of writing it, but let's write it anyway. So minus 24. So your answer is E. Just looking at all my answers. Okay. Part B, so short answer. Sketch the graphs of the following quadratic relations, labeling the turning point and the y-intercept. All right, so when I look at this, I see it's a parabola that's been reflected because of this negative, and it's been shifted down 4. So if it helps, you can rewrite this in turning point form. Sorry, just having a little, doesn't matter if that's a 0. Now, this negative, if you're going to rewrite this, if I've taken that out, it doesn't, sorry, I probably don't need to do that. It doesn't apply to that negative 4 because I'm going to write that negative 4 here. So my turning point is at 0, negative 4, which kind of makes sense because I know the graph has been reflected and it's been shifted down 4. So we go down to, oops, it's got to be negative 4 and then just drawing it like that. So probably the turning point and the y-intercept are the same thing. So I've written there at 0 and negative 4, but let's just write the coordinates there. All right, this one here, we have a turning point at negative 3, 1. So remember this plus sign we can rewrite as negative, negative to remind us that 8 is negative 3. And to get your, so this graph is a positive graph that's been shifted up 1, so it doesn't have any x-intercepts, but your y-intercept, we let x equal 0. So when x is equal to 0, y is equal to 0 plus 3 squared plus 1. So 3 squared is 9 plus 1 is 10. So your y-intercept is at, I'll just put 10 up there. The turning point is at negative 3, 1. Negative 3 here. 1. So we're about here. And we go up. And we draw it as well as we can. Not much of a scale, but you need to just show that turning point. So I've got it listed here, negative 3, 1. So it's gone to the left 3, up 1. And your y-intercept is 10. All right, so let's move on to question 2. For the quadratic with the rule x squared plus 2x minus 8, use factorization to find the x-intercepts. So we need to find two numbers when multiplied give us negative 8 and when add give us 2. So I always find it's a good idea just to write your brackets first, and we're dealing with the x variable. So I write x. Because this is a negative, that means one of your numbers has to be a positive and the other one has to be a negative. And 4 times 2 gives me 8. So which one is negative? Because this is positive 2, it's going to be positive 4 minus 2. So your x-intercepts, you let y equal 0. So that means x plus 4 equals 0 or x minus 2 equals 0. So x equals negative 4 and x equals 2. Use symmetry to find the turning point. So your turning point is halfway between your x-intercepts, so you just add them together. Okay, so negative 2 plus 2 is negative 2, over 2 gives you negative 1. You could also, if you have done the quadratic formula part of chapter 7, you could use negative b over 2a if you like. But your turning point is just halfway between those 2 points. Okay. And once you've got the x, so that's just your x coordinate. So I'm just looking out my window, someone up my driveway. It's quite weird, I don't think they're there for me. Okay, so to get your x coordinate, you can substitute it either into expanded form or into factorized form. So let's do it into factorized form just because I think it's a little bit easy. Negative 1 plus 3, sorry, plus 4 is 3. Negative 1 minus 2 is negative 3. Okay, so negative 1 plus 4 is 3. Negative 1 minus 2, sorry, getting distracted by this car. 3 times negative 3 gives you negative 9. So you're, oh, sorry. Oh, yeah, sorry. I thought it was asking for the axis of symmetry. So we are doing the turning point. So your turning point is at negative 1, negative 9. All right, so let's plot these on. And when you're in expanded form, your constant is your y-intercept. So my y-intercept is going to be at negative 8. Turning point is at y equals negative 9. So I'm going to put that on, and negative 1. My x-intercepts are at negative 4 and 2. So let's change the colour just to make it a little bit easier. So to see, so there's our turning point. We go through that y-intercept, x-intercept go up, and then we do the same. Whoops. Oh gosh, that was terrible. But anyway, you get the gist of it. All right, and there's our graph. All right, question 3. For the quadratic equation with the rule x squared minus 6x plus 4, complete the square, write in the rule in turning point form, enter turning point, determine the turning point coordinates. All right, so we did completing the square before, so we keep the same, the first two terms the same. We take the coefficient of x, so negative 6, divide it by 2 and square it. Then we subtract it. And then what's that last number? Plus 4. Okay, so now we're factorizing the first 3 terms. So we're going to have x, whatever this number is in the bracket, so negative 6 divided by 2 gives you minus 3. And then we square it. All right, negative 6 on 2 is negative 3 squared is 9, so minus 9 plus 4. So we got y equals x minus 3 squared minus 9 plus 4 gives you minus 5. All right, so sketch it on the graph, labeling the y-intercept and the turning point. Did we get the y-intercept? So your y-intercept, remember, when it's expanded, is the constant. So your y-intercept is 4, and we're just going to put that on. Your turning point, remember, is h and your k, so it's going to be 3, negative 5. So 3, and I'll do negative 5 down here. Now, we don't have the x-intercepts. It doesn't say to do the x-intercepts, but if you're doing the x-intercepts, I can clearly see they're going to be surds. So let's just draw the graph. I guess it goes something like that. All right, it doesn't say to label the x-intercepts, but if you were, you just let y equal 0. So we're going to have x minus 3 squared minus 5 equals 0. X minus 3 squared equals 5. So x minus 3 equals square root of 5, or plus or minus the square root of 5. So x equals 3 plus root 5, and x equals 3 minus square root of 5. So they're your 2 points here. So you can see you're either side, you're negative root 5 either side of 3. Now, I did have a great question just for when I was helping a student individually, and said, well, how do you know what this is? So the square root of 5 is somewhere between 2 perfect squares. So you think, oh, what perfect squares is it in between? So it's in between the square root of 4 and the square root of 9. So the square root of 4 is 2. The square root of 9 is 3. So it's somewhere between 2 and 3. So that means when we do 3 minus root 5, we're still going to be on this side, on the positive side of our x-axis. Okay, so it's good to think when you're graphing, and you probably won't do this until you do methods, but what is the square root of 5 approximately? And you would do it that way, looking at which 2 perfect squares it fits in between. Okay, so the square root of 4 is 2. The next perfect square is 9, so the square root of 9 is 3. It's probably closer to 2 than what it is to 3. Okay, question C. Oh, I thought we were going to have to do the x-intercepts. I'm like, oh, I just did it. Okay, determine the coordinates of the points where the line x minus 6 intersects the parabola x squared minus 6x plus 4. So for this one here, we've got two simultaneous equations basically. They're both y equals, so I just let them equal each other. And then what I would do is bring everything over to one side. So I'm going to have x squared minus 6x. Then we've got this x, so I've got to minus another x plus 4, and then this 6 comes over as plus 6 equals 0. Sorry, I'm just working away. Plus 10 equals 0. So then you can see that can easily be factorized. So two numbers when multiplied give you 10 and when add give you negative 7. Beautiful. We're going to have x minus 5 and x minus 2. So it's nice that we get some numbers. So x equals 5 and x equals 2. So basically what this equation is saying is we've got a parabola and then we've got a line going through it. So and it's asking what are these 2 points. It is asking for coordinates, so we do have to substitute these values back in. So when x equals 5, y is equal to 5 minus 6, which is negative 1. And when x equals 2, y is equal to 2 minus 6, which is negative 4. So your coordinates are going to be 5, negative 1, and 2, negative 4. But girls, you won't be tested on that because I forgot to delete this before I gave you the test. But it's still good to do something like that. All right, so consider the parabola given by the quadratic equation. So your y-intercept is always your constant. Yeah, so when x equals 0, you can substitute x equals 0 into there, but it's the same when you do linear. Y equals mx plus c. You already know your y-intercept is c, your constant, same in this case. So your y-intercept is 7. If you wanted to write it as coordinates, it's 0, 7. Use a discriminant to determine the number of x-intercepts. So remember your discriminant, which we write as triangle or delta. We've got, oh gosh, b squared minus 4ac. So in your quadratic equation, that's just what is under the square root sign. So b is negative 8, so we're going to do negative 8 squared minus 4 times 2 times 7. So 8 squared or negative 8 squared is 64 minus 8 times 7, so minus 56. So we get 8. Number of x-intercepts, so we say therefore we have 2 x-intercepts. All right, use a quadratic formula to find any x-intercepts, rounding to 2 decimal places. So your quadratic equation, b squared minus 4ac over 2a. So we've already got this bit under the square root sign. So I'm going to just do the rest. So negative b, so b was negative 8, so it's going to be just 8 plus or minus the square root of 8. I just want to check. Okay, so b, the coefficient of x was negative 8, and a was 2, so that's over 2. Now, it did say you can round to 2 decimal places. I'm just going to leave it in third form. So if I simplified this third, let's just do that first. So square root of 8 becomes 2 root 2. So that's all over 2. So your x-intercepts, everything divides through by 2. So it's going to be 4 plus root 2. Okay, so that 2 and that 8 goes into that 8, and that 2 goes into that 2. And then we've got 4 minus root 2. Okay. Use x equals negative b over 2a to determine the turning point. So x equals negative. Now b is negative 8. I like to put in brackets because we don't want to get our negatives mixed up. And then a is 2. So negative and a negative just gives you 8. So 8 over 4 gives you 2. And then we substitute 2 back into our equation to get the y-intercept. So what is it? 2x. I'll just do it next to it. So the y-coordinate is 2 times 2 squared minus 8 times 2 plus 7. Running out of room. So we've got y equals 2 squared is 4, 2 times 4 is 8, minus 16 plus 7. So we've got y equals negative 8 plus 7 is negative 1. So your turning point is at 2, negative 1. And now we've got to sketch it. So, all right, let's start with our y-intercept is at 7. Our turning point is at 2, negative 1. So it's here. That's your turning point. Now your x-intercepts, I didn't do them to 2 decimal places. Now the square root of 2, I know from doing a lot of maths in the past, is about 1.4. So we've basically got about 5. We're going to be doing around 5 and 4 minus 1.4. So we're going to be doing around 2 something. But I just go either side. Yeah, and I feel like did I make a mistake somewhere? Because I'm thinking, is that supposed to be, that's supposed to be a 4? I'm just thinking that this should be either a 2. Okay, it is. Good. I'm glad I figured that out. So that's my error, girls. 2 times 2 is 4. So this is 4. This is 4. And so that makes this one 2. And let me just check. So 4 goes into 8 twice, and then we've got 2 root 2 over 4. So that's still going to be over 2. So that's going to be 2 over 2. That only, yeah, so now that's right. Doesn't make any difference to our turning point. So this is 2 plus 2 root 2. Oops. Gosh, so many numbers. Let's just get rid of that 2. 2 plus root 2 on 2. And then this one here is 2 minus root 2 on 2. And then let's just graph it. Okay, so I'm going to do that on the calculator as well. Oh gosh, sorry, that was supposed to go through 7. I'll quickly do that on the calculator. Let's get my calculator up. All right, so we'll just go to graphs. So it's 2x squared minus 8x plus, whoops, not plus 8, plus 7. There's your graph. So I might just change my window a little bit. So I don't really need to go all the way to negative. So let's just do negative 5. And might do the same. Yeah, max I'll go up to 10 because our y-intercept was at 7. Okay, so key features, remember, we go to analyze graph, it's a minimum. So we go to the left, to the right. There it is, your turning point. Your y-intercept, we can go to trace, graph trace. So your y-intercept is when x equals 0. So we'll just type in x equals 0. There it is, 0, 7. Now your x-intercepts, we'll go to 0, analyze graph 0. Just go to left side, right side. So there you can see it's 1.29, and I'll explain in a sec why it's not always a good idea to do on here. Okay, so there's your other one. So if we add a page, so control add page and add calculator. So we're just going to solve it by, I was going to say by hand, but we're not doing it by hand. We're solving it using solve on the calculator. Minus 7x plus 8. Now we're letting that equal 0 because your x-intercepts are when y is equal to 0. Oh, what did I do wrong? Did I get my 8 and my 7 around the wrong way? I did, didn't I? Sorry. So if it says false, it just means there's no x-intercept. So here's the solutions. I separated the numerator, the terms on the numerator, so that's why it looks a little bit different, but I can tell you that they are the same. If you wanted a decimal answer, just press enter and then do control enter. We'll put it in decimals and you can see you get more decimal places. So when you go into methods, you should always use exact values as you work through a question, and then your final answer, if it asks for it in decimal point, then decimal form, then you can do it there. All right, girls. Good stuff. Just email me if you need help with anything else. Okay, bye.